My name's Evan, and my colleagues Katie, Quentin, and I will be discussing the 3 key decision points of successful data science projects. We'll be framing each of these in relation to 3 unique projects that each one of us was involved in across life underwriting, cybersecurity, and marketing at our company, MassMutual. We will have time for questions at the end as well. So MassMutual is a financial services institution whose primary product is life insurance. And within our enterprise technology and experience group, we have a wide range of teams working to further the usage of technology across the company with a particular focus on delivering holistic data science solutions. So just before we get into this, I wanted to start with a quick exercise. Make sure everyone's still awake. I know it's been a long day of talks. So please raise your hand if you've ever had an idea for a data science project at your company. Keep your hand raised if that same idea was developed into a full-scale data science solution. Okay, right. So as we can see, ideas for data science projects are plentiful. There's so much we can, use, assuming we have the infrastructure in place. But turning an idea into a robust, value-generating solution is much harder in practice.
So to aid in this process, MassMutual has developed a data science project lifecycle across a decade of successful and unsuccessful projects. This process takes us from idea generation and scoping through development, deployment, and continuous service. While this may seem similar to a software development lifecycle that many of you are familiar with, this is more helpful to think of as an innovation funnel, where we put in a ton of ideas, but only those that are most likely to be successful are actually pursued. So MassMutual is first and foremost a life insurance company. So I'll give a 3,000-foot view of life insurance first. Life insurance is a financial tool that helps individuals secure their future and protect the ones they love. A life insurer agrees to pay a beneficiary a large sum of money in exchange for the policyholder paying a small sum of money for a predefined period of time, generally over the course of their life for a couple decades. This typically requires an estimate of an individual's expected lifetime when they apply, which we refer to as mortality risk. And the process of calculating and analyzing the data to assess that underwriting. Use medical manuals to group individuals into broad classes of mortality risk, which are dictated based on point-based systems where debits and credits are assigned for medical and behavioral attributes, such as family histories of certain diseases or certain medications that someone might be taking. A life underwriter reviews all the relevant data in an application to complete an overall assessment, which determines the discrete risk class that a policy falls into. Actuaries then use the cost of covering mortality risk over the lifetime of a policy, based on that aforementioned risk class, to determine the premium that a policyholder will be paying. We also work with reinsurance companies. We ensure that they approve of the underwriting process we use, and they assume and further diversify a portion of our financial risk. So recent advancements in machine learning and the increased availability of digital medical records have provided a ton of new opportunities and challenges to every industry, and life insurance is no exception. At MassMutual, we've spent the past 20 years curating one of the largest and most comprehensive application data sets in the industry, with over 1 million applicants. The intuitive question to ask then, we've got a big data set, we're trying to predict discrete quantities, how do we apply machine learning to this task? The first broad idea that we start with, the low-hanging fruit if we're applying predictive modeling to this case, is how can we improve the speed and accuracy of mortality risk assessment? We learn more about how we can achieve this with our subject matter experts, by interfacing with, I think I may have cut out there, our subject matter experts as early and as often as possible. So for this project specifically, our team worked really closely with our underwriters, with our medical team, and with actuaries, reinsurers, and our legal partners, including our compliance at MassMutual. As the end users of this project, underwriters are the business partners that we are best positioned to support directly with this system. Ultimately, we want to empower them, reduce their time and labor per policy, and in doing so, improve risk assessment across the board. As we think about predictive modeling in life insurance underwriting, we also want to bear in mind that using predictive modeling in this or any context raises legitimate questions by consumer advocates and by regulatory bodies, given the many recent scenarios where data and algorithms are misused. So, in addition to that, all the risk that we take on as insurers has to be auditable and shareable with our reinsurers. So in doing so, we need to make sure that in order to empower underwriters, all of our models are completely transparent and explainable. We have no space in underwriting for black box models. So this visual illustrates the algorithmic rule system that we developed to meet this business need. A life insurance applicant submits several sources of underwriting data requirements. we send lab test results and application answers to the mortality model, which returns a life score, recommended risk class, and model explanations. These explanations are generated using a kernel SHAP algorithm to return additive feature contributions. And the rule engine then combines all of our underwriting data with the model output and presents the information to a human-in-the-loop underwriter who provides the final underwriting decision. This system has resulted in a greatly improved operational efficiency at MassMutual. Automating underwriting decisions has saved us millions of dollars in labor costs on a growing portfolio of policies with over $100 billion in protective benefits. Our time to issuance has decreased significantly, especially for our healthiest risk classes. As a result, this has been a driver for a decrease in decline rate for those healthiest risk classes. And intuitively, a retrospective study of the model has found that we've led to a long-term benefit of reduced claim experience for the company. So this machine learning-based system has been a tremendously successful data science solution within our company and is available today as LifeScore 360, which is a service that other carriers can now use for improved life underwriting as well. The takeaway we want to leave you with here is that we're able to narrow in on our exact business need and the nature of our solution by interfacing frequently with our subject matter experts and business partners, especially with the end users of our solution, but with everyone is important, during the rationalize and plan stage. This is well before we reach our develop stage or writing a single line of production code. For the next step in this stage, Evan will be discussing the next decision point, right-sizing your solution.
All right, thanks, Quentin. So cybersecurity is a critical function of every enterprise. And at MassMutual, we've formed a data science group to collaborate with our enterprise cybersecurity team on relevant problems. Traditional cybersecurity methods are most effective at capturing pre-identified patterns of malicious behavior, but attackers are constantly evolving their techniques. A data-driven approach can allow for flexible controls that adjust to the ever-changing threat landscape over time. With the goal of improving enterprise security posture, we identified user behavior analytics, or UBA, as an area that could benefit from the application of data science techniques. UBA is concerned with categorizing normal or baseline behavior on an individual level, then quantifying deviations from that baseline that may represent malicious behavior. Here we focus specifically on MassMutual employees with the goal of identifying account takeover events, which could lead to costly negative outcomes like data exfiltration or malware placement. And so naturally, UBA is a good fit for data science because we can make use of a wealth of activity logs across sources like email, authentication, and file sharing to build up these individualized baselines over time. So right off the bat, we knew that our solution needed to be fast, interpretable, and interoperable with existing systems for cybersecurity case generation. So by building backwards from this desired end state, we developed a right-sized solution that addressed each of our needs. Cyber Anomaly Threat Capture Heuristics, or CATCH, is a suite of models built using techniques from statistical anomaly detection. Each model corresponds to a tactic in the MITRE ATT&CK framework, an industry-standard knowledge base of attacker techniques, which we use to ensure we're looking for the most impactful anomalies possible. Additionally, our use cases are prioritized based on gaps identified by our internal red team, a group who simulates attacker-like behavior for the purpose of gauging overall enterprise security posture. So to implement CATCH in production, we developed a data pipeline to ingest, aggregate, and score hundreds of thousands of event logs per day to ultimately deliver alerts to cybersecurity analysts at a daily cadence. So efficient data structures are used to allow this computation to be performed quickly, and we also used an object-oriented programming approach for better scalability. So as you can see in this process diagram here, we begin by ingesting logs from various sources and running them through our anomaly-based approach. At the same time, a suite of well-tuned custom rules built by our threat detection engineering team are also applied. We'll then take the outputs of both of these processes, group them by entity, and weight the relative contributions of each input to ultimately threshold them and determine if the set of activity warrants a human looking at it for review. So altogether, CATCH not only greatly improved our security posture by outperforming a competing vendor solution, but also generated over $1 million of value by allowing us to build in-house. And because of the decisions we took to right-size it along the way, It perfectly suited our identified business need and will also be scalable towards future use cases as we continue to iterate on it moving forward. So to wrap up, data science is such a fast-moving and exciting field. I think it's really easy to get caught up in a new model or technique that comes out and then naturally begin brainstorming different ways that it could be applied at your company. But this is fundamentally approaching the development process through the wrong lens. So instead, the models and techniques chosen should be dictated solely by the properties that would be required to satisfy your identified business need. So always make sure you're focusing on solving problems and not just using a specific technique. Now, Katie will talk about her work in defining value in the marketing domain.
Hi all, my name is Katie and I'm a data scientist for our marketing and distribution domain. All right, so data science plays a key role in marketing at MassMutual. Marketing spend at MassMutual actually spans across various channels, from traditional channels such as TV and radio to digital channels such as search engine marketing. Marketing sponsors sought assistance from data science in order to quantify how marketing spend drove business results. Particularly, they were interested in the relationship between the top of funnel marketing spend for different channels and campaigns and bottom of funnel sales or conversions. Data science can use something called the mixed media model, or MMM for short, in order to find this relationship between the top of funnel marketing spend and the bottom of funnel conversions. Essentially, mixed media models are a regression model in which marketing spend are the features of the model and conversions are the target variables. The learned coefficients of the regression model tell us the specific attribution for different marketing channels and campaigns on conversions. Before we start any project at MassMutual, especially a data science project, we always want to determine how do we capture value in this project. Now, we knew that the marketing sponsors were considering purchasing a vendor solution for the mixed media model. So our project captured value by providing an in-house solution that was customized to MassMutual's business needs, and we were able to do vendor cost avoidance. However, this was not the only way that we captured value with this project. We also captured value through an optimization step. Let's say we want to find the optimal marketing mix between different channels and campaigns. We have a regression model in which we measure the relationship between different channels and campaigns and conversions. So then we can perform constrained optimization where we maximize the number of conversions subject to marketing spend. In that way, we're able to capture value through that optimization step as well. Overall, it's really important to look at value in multiple ways, and also to reevaluate the value estimation of your project throughout your data science project in order to ensure it's successful. All right. So I'm going to give the last slide, but we really want to have time for questions, and we are going under, so please stay if you have questions on any of our projects. Overall, ideas for data science projects are common, but going from ideas to value-generating data science solutions is hard. At MassMutual, we use the data science project lifecycle to facilitate this process. With the rationalize and plan stage, we highlighted 3 key decision points of identifying a business need, right-sizing your solution, capturing value in your project. In underwriting, the MassMutual mortality score showed us how continuous engagement with subject matter experts allowed us to identify a crystal clear business need. In cybersecurity, we demonstrated how Catch was right-sized to meet all of the business requirements. In marketing, the MMM project highlighted how value for projects can be captured in multiple ways through both vendor cost avoidance and through optimization. By involving subject matter experts early and often, by focusing on problems instead of tools, and by looking at value in a holistic way throughout your project, you will be on the path for a successful value-generating data science project before writing a line of code. Thank you.